How do you think neural networks perceive us? Maybe they see us like this. This is how a dog sees you. Or perhaps like this. That's how a shark sees us. Or maybe like this. Still not, that's how a snake sees us. But what if I tell you that neural networks see the world differently? Not through the eyes of animals, but something out of a comic book, with lines and shapes. Almost like in the movie The Matrix, where everything is represented as streams of numbers. So why does it look so abstract? Why simplify something that can already be seen in 4K resolution? It's all because these simplified images are easier to convert into numbers. And for neural networks, the entire world is just numbers. Pictures, videos, text, audio, everything can be turned into numbers. But why numbers? To transform one set of numbers into another, like turning a text prompt into an image, or converting a voice from English to Portuguese.
Tower in the middle of nowhere, and I don't blame you, and now we're stuck on this stupid... Es todo por mi culpa.
Neural networks work with numbers because they are essentially mathematical models. When data comes in as images, text or sounds, it's converted into numerical representations. Every image becomes a grid of numbers, where each number represents a pixel's intensity in grayscale or RGB channels. Essentially, the image is a multi-dimensional array or tensor. Too complicated. Okay, let's simplify. Imagine a picture, say a drawing of a dog. The neural network doesn't see the picture like you do. Instead, it transforms the image into a long series of numbers. Each number indicates how bright or dark a pixel is. It's like in some comics where pictures are drawn using dots or lines. Once the image is converted to numbers, the neural network processes them to understand what's in the picture. It's like a guessing game where at each step the network decides what to do next with the numbers. It goes through several stages, with each stage trying to understand something new, like identifying the dog's shape or its size. Why is it so complex? Even so, the neural networks can work with highly detailed and complex images. Sometimes it's helpful to simplify the picture first. This simplification makes it easier to identify some essential parts. It's like how we might draw some simple diagrams to understand something complex. What about sounds? Sound data is also converted to numbers using methods like spectrograms or MFCC. When we hear sounds like voice or music, the neural network don't listen to it like we do. Instead, it converts the sound into a long series of numbers. That's how Shazam works. It's similar to how we record sound as waves on a graph. These numbers show how the sound volume changes over time.
Agora consigo falar português sem eu ter aprendido.
When you speak, your voice creates sound waves, which can be converted into numbers. This is done by using a special equipment and software that records changes in the loudness and frequency of the sound in the form of numbers. These numbers represent a graph of the sound that a neural network can analyze. But for all of this to work, significant computational power is required. For instance, playing a game like GTA might only require a single mid-range graphics card. Now imagine 10,000 graphics cards working together. That's the scale of power Microsoft used when it helped OpenAI train its chatbot, ChatGPT. Back in 2019, Microsoft invested $1 billion into OpenAI and agreed to build a supercomputer specifically for this startup, utilizing artificial intelligence. You can ask, why so much power? Such immense power allows the chatbot to learn rapidly. They can even learn things we haven't explicitly taught them, unlocking new abilities. Neural networks learn by analyzing massive data sets. For example, they might read millions of texts to understand how words and phrases are used in different contexts. During training, the model analyzes the relationships between words, their meanings, and their context. This allows the network to grasp not just basics of language, but also the subtleties that come with different accents, pronunciations, and even the nuances of grammar. The learning process for neural networks happens gradually. At first, the model makes many mistakes, but with each iteration, it corrects those errors and improves its understanding of language. This is much like how kids, or even we, learn through practice, gradually getting better over time. And sometimes neural networks make discoveries that no one asks them to make. For example, the Megasyn neural network has developed 40,000 new substances that resemble powerful nerve poisons. Impressive, isn't it? The AI has already figured out how to kill us. But there are some positive discoveries. For example, the GraphCast system can predict the weather 10 days ahead with more accuracy than traditional meteorologists. In fact, GraphCast has outperformed existing technologies by 90%. There are just one catch. The developers don't fully understand how the neural network makes its predictions. So for now, it serves only as a supplement to traditional forecasting methods. Another example is a neural network developed at the China Ship Design and Research Center, which designed a warship in just one day, a task that would typically take a human a year. Or one more thing, AI has learned to read minds with an MRI machine, and we Laserbacks still haven't. Neural networks often arrive at unexpected solutions. Why? Because AI developers are in many ways navigating in the dark. They create a neural network first and only later discover what it's capable of. This uncertainty has led to growing concerns that neural network could eventually spiral out of control. There is a leaked roadmap circulating online that allegedly outlines the OpenAI plans for the next 5 years. If it's to be believed, by 2025 AI agents will take over all household chores. By 2026, OpenAI will create the most powerful neural network, known as AGI, which will operate at a human level and replace all professions. In 2027, AI will surpass human intelligence and take over solving global issues. By 2028, all diseases will be eradicated as ACI. Artificial superintelligence will create nanorobots that can eliminate all viruses and bacteria. And by 2029, the superintelligence will take control of the world, forcing Americans, Chinese, Ukrainians and Russians to unite and fight Skynet. By the way, I post all the latest news about technology startups on my Telegram channel for free, so don't forget to subscribe. The link is in the description. The nature of a neural network is such that it is almost impossible to predict the end result, and even at current power level, the AI is already capable to make independent decisions. But imagine when we increase that power by 100 or even 1,000 times. Then AI will be able to find cures for cancer, or destroy and enslave our world, or even pass CAPTCHA on its own. Oh, wait. AI can already resolve CAPTCHA on its own. For those who don't know, CAPTCHA is a method to distinguish humans from robots. Did you know that by solving CAPTCHAs you were actually helping Google's AI learn to see? In old CAPTCHAs, there were always two words. The first one let you access the site, but the second didn't actually matter. You could type anything and still get through. But why was the second word there? It was an old word scanned from newspapers or books that the AI couldn't recognize. Maybe because it was crossed out or smudged. The idea was that if you got the first word right, you'd probably get the second one right too. And if 9 out of 10 people type the same thing, eureka, the AI would learn that word. Those of you who solved CAPTCHAs correctly helped digitize a year's worth of the New York Times archives in just 4 days. We taught AI to read books, and now reading is no longer something that separates a human from machines. By now you probably noticed that most CAPTCHAs feature images. Have you ever wondered why they often show traffic lights, crosswalk, buses and bicycles? It's not just random. These images are taken from Google Maps, and when you identify them in CAPTCHA, you're actually helping Google's self-driving cars learn to recognize real-world objects. Yes, we are all quite literally teaching AI how to replace us for free, and you have done it so well that now AI can identify these objects better than humans can. CAPTCHAs didn't just make us listen to audio files for no reason either. They were also training neural networks to understand and differentiate between sounds. Much like they trained AI to recognize images. But what if instead of teaching neural network to recognize street signs, we train them to recognize our faces? In the past we used to say that makeup could fool a neural network into not recognizing a face. But now AI can scan your face using infrared light, making skin color irrelevant. Drones equipped with this technology can now capture entire 3D models of cities. This technology helps cities become smarter and more efficient, but it also makes them completely transparent, leaving you with nowhere to hide.
And they just learned to predict, like, this is where the human beings are. Then they took away the camera. So all the AI had was the language of radio signals bouncing around a room, and this is what they're able to reconstruct. Real-time 3D pose estimation. So suddenly AI has turned every Wi-Fi router into a camera that can work in the dark, specially tuned for tracking living beings.